Hi everyone. Today we will explain the rational function and the end behavior. In the previous videos, we explained what do we mean by rational function and what is the domain, what is the vertical asymptote, what is the whole, what is the zeros, and now we're gonna go to the end behavior actually and a horizontal asymptote. So let's start. Okay. The end behavior of the rational function will be most affected by the polynomial with a greater degree, as the values will dominate the values of the rational function for the input values of a larger magnitude. So there are two different possibilities for the end behavior of the rational function, which we call end behavior asymptote, a horizontal asymptote, or a slant asymptote. So when we ask about the end behavior of the rational function, we can search about either the horizontal asymptote or a slant asymptote. Let's see the cases. What are the horizontal asymptote, when we can have a horizontal asymptote, and when we can have a slant asymptote. So as we know in the rational function, if we have a polynomial over polynomial, so let f of x be p of x over q of x. Now this is the p of x is a n x to the power n whatever over qx, which is p m times x to the power m whatever. So what we're gonna do now? Sorry. Okay. So we're going to look at the degree for the numerator. What is the degree here of the numerator? The degree is the maximum degree, which is n. And the degree for the denominator is equal what? Is equal m. So here actually we will get three different cases. So case number one, if the degree of the numerator is less than the degree of the denominator, so if the degree of the denominator is greater than the degree of the numerator, so it will take the horizontal asymptote down to y equals 0. So case number one, if n is less than m or m is greater than n, so the degree of the denominator, the degree down is greater than the degree up. So in this case, we will take the horizontal asymptote where to y equals 0. So let's take example for that. Let's say suppose f of x is equal here. So it's equal for 3x squared plus 2x minus 1 over 5x to the power 4 or minus 3x cubic plus 2x. So in this case, what is the degree of the numerator? The degree of the numerator is equal to, according to the degree of the polynomial up, the maximum degree is equal to 2. What is the degree now for the denominator? The degree for the denominator is equal to what here? Is equal to 4. So since the degree of the denominator is greater than the degree of the numerator, so in this case, we're going to take the asymptote down where to y equal 0. So here we have a horizontal asymptote at y equals 0, and where y is equal 0 actually on the x-axis. Okay, case number two. If the degree of the numerator is equal to the degree of the denominator. In this case, we have a horizontal asymptote where we're going to take the coefficient over the coefficient. It's going to be y equal a over b. Let's see example also here for case number two. So f of x is equal, let's say it's 3x squared plus 2x minus 1 over 5x squared plus 4. So the degree of the numerator is equal to 2. And the degree for the denominator also is equal to 2. So here we have equal degree between the numerator and the denominator. So do we have a horizontal asymptote? Yes, we have a horizontal asymptote, which is equal here. Y is equal 3 over 5. We're going to take the coefficient over a coefficient. Okay, case number 3. Now, if the degree of the numerator is greater than the degree of the denominator, the degree up is more than the degree down. So in this case, the rational function has no horizontal asymptote. And the end behavior asymptote is the quotient polynomial function that is found when the polynomial we divide the p of x over q of x. So if that polynomial is linear, so the rational function has a slant asymptote parallel to the graph to the line. So case number 3 now. If the degree of the numerator is more than the degree of the denominator, so we're going to take the horizontal asymptote out. So no horizontal asymptote. So what is the end behavior in this case? The end behavior in this case, we're going to divide the numerator over the denominator, and the quotient we will get is the end behavior that represents what of the rational function. And if the quotient is a linear function, so in this case we're going to say it's a slant asymptote. So case number 3 here, f of x, suppose 3x to the power 5 minus 4x cubic plus 2 over x squared minus 3x plus 1. So in this case here, the degree of the numerator is more than the degree, is greater than the degree of the denominator. So no horizontal asymptote. No horizontal asymptote. So to find the end behavior for this function, we have to divide the numerator over the denominator and see if it's a linear. So it's we get a linear here. So in this case, we will get what? We will get a slant asymptote. Okay, so let's see this example now. Find the horizontal asymptote of each of the rational function. So we have 5x over x squared minus 9. So here, the degree of what? The degree of the denominator is more than the degree of the numerator. So since the degree down is more, it's going to take the horizontal asymptote where we have a horizontal asymptote at y is equal to what? At y equal to 0. So our end behavior is going for where? For y is equal to 0. So as the function increasing to the right, the end behavior is approach to touch 0. And as the end behavior is going from the end side, so also the end behavior approach touch what? Approach touches 0. So we can see here the end behavior of the function. It's the end behavior. So as x going to the negative infinity, the f of x or the function approach to touch the 0. And here is the same. As the function going to the positive infinity, or the value of x is going to the positive infinity, so the value of the function is what? Is approach to touch also what? Is approach touches 0 from the both sides. So we can say here the end behavior from the both side is going to where? Is approach touch the 0. Why? Because we have a horizontal asymptote is equal to what? Is equal to 0. Okay. Let's see this one. Now, what do we have here? We have an equal degree or equal power between the numerator and denominator. So since I have the equal power, so direct we will get a horizontal asymptote, of course. And the behavior is going to be for the horizontal asymptote, y is equal what? Coefficient over coefficient, 3 over 2. So it's equal here 3 over 2. So here we can say from the graph, from the graph, as x here going to the negative infinity, f of x or the value of the function is going to approach 3 over 2. And as x going to the positive infinity, the value of the function is approaches also what? Here is approach to touch the 3 over 2, which is the value of what? The value of the horizontal asymptote. Okay. Let's see now. h of x is equal x cubic minus 3x squared plus 3x plus 1. Now we need to find here the end behavior. So since now the degree of the numerator is more than the degree of the denominator, so actually here we don't have any horizontal asymptote. So what do we have in this case to find the end behavior? We have to do the division. I need to divide the numerator over the denominator. So let's divide this together to find the answer. So let's divide it here. Okay. It's x cubic minus 3x squared plus 3x plus 1 divided over x minus 1. So as we took in that long division here, I just only need to take the first term over the first term. x cubic divided by x is going to be what? X squared. X squared times x is going to be what? X cubic. X squared times negative 1 is going to be negative x squared. So now we're going to minus and put the parentheses. X cubic minus x cubic, it's 0. Negative 3x squared minus x squared. So it's going to be actually here plus. So the answer is what? Negative 2x squared. Take this down, plus 3x. Now negative 2x squared divided by x is going to be what? Negative 2x. Now negative 2x times x, negative 2x squared. Negative 2x times negative 1 is going to be what? 2x. So what do we have to do? We need to subtract. So 3x minus 2x, so the answer is equal to x. Now what do we have? We have 1. Now x divided by x is equal to 1. 1 times x is x. 1 times negative 1 is negative 1. So now what do we have to do? We need to subtract. So when we subtract this here, so the remainder is equal to 2. So actually here, this is the quotient. This is the answer of what? Of the division. And this is the remainder. So how we should write the answer of the division? It's x squared minus 2x plus 1 and the remainder over what? X minus 1. So I just care here about the quotient. The quotient of the division represents what in the rational function? Represent the end behavior of our rational function. So we can say now that the end behavior from the infinity or positive or negative infinity is going as a quadratic function, as here with as the result we get from the long division. So here according to this graph, okay, let's erase the division to see the graph. Okay, so as we draw here the end behavior, that the function we got x squared minus 2x plus 1 or the answer, we will get this one here. So what we can say about the end behavior now? As x going to the negative infinity, f of x is going up where? To the positive. And as x is going to the positive infinity, f of x also is going to the positive infinity. So since the end behavior is a quadratic and it's positive open up, so the end behavior of the function is going up from the both sides also. So the end behavior, it's the same like the end behavior of what? Of the quotient that we get here in the answer. Okay, now let's do this example, x cubic over x squared minus 9. So this example here, what we can realize that the degree of the numerator is more than the degree of the denominator, so we don't have any horizontal asymptote. So to have the end behavior, we must do what? The long division. So let's divide now x cubic plus 0x squared plus 0x plus 0 divided by x squared plus 0x minus 9. And as we said, when we divide, we have to make sure that all the terms are exist. So x cubic divided x squared, so the answer is x. So x times x squared, it's x cubic times 0x, so it's going to be 0x squared. Then x times negative 9, so it's going to be negative 9x. So now what do we have to do? We need to minus. So we remove this one, 0x minus 0x is going to be 0x squared. Then 0x minus 9, so we will get here plus 9x plus 0. So the remainder actually here is equal what? 9x. And what is the quotient? The quotient is equal x. So how we can write now the answer? So the answer is equal x plus 9x over x squared minus 9. So the end behavior here, it's only what? It's only the quotient. So we have the quotient here, actually it's a linear. So the quotient represents what? It represents a linear function, y equal x, so like this. So here what? This is what the end behavior of our rational function. So what do we mean now by this end behavior? So the end behavior asymptote is y equal x. So the quotient after completing the long division, since it's a linear function, this is known as a slant asymptote. So since our end behavior from the division is a linear function, now we can say that our end behavior is what? Is a slant asymptote. Okay, so since it's the slant asymptote, as x approaches positive or negative infinity, so the graph and its asymptote appear to be identical as the graph of j of x run parallel to y equal x. So as x go to the negative infinity, also the function or f of x, or it's yes, going to the negative infinity. And as x go to the positive infinity, also the function go where to the positive infinity, is going parallel with our linear function, the end behavior of the rational function going with the end behavior of what, of the slant asymptote. And this is like different than the one we got the end behavior as what, as a quadratic. So the quadratic from the both sides is going to where, is going to the positive infinity, but here is going with what, with our linear function. Okay, let's take now also this example for the slant asymptote. Now x cubic minus x squared minus 4x plus 4 over x squared minus 2x minus 3. So since that numerator is the degree of the numerator greater than the degree of the denominator, so that we don't have any horizontal asymptote. So what is the end behavior? Then end behavior we have to divide. So since the degree of the numerator is more than the degree of the denominator by 1, so we will get the end behavior. Of course, it's going to be what? A slant asymptote, linear function. So let's find our linear function by divide them. Okay. Okay. So we have x cubic minus x squared minus 4x plus 4 over x squared minus 2x minus 3. So x cubic divided by x squared is equal to what? Is equal to x. Now x times x squared is equal to what? X cubic. X times negative 2x is going to be negative 2x squared. Negative 2x squared. And x times negative 3 is going to be what? Negative 3x. So let's minus them. So this is goes 0. Now negative x squared minus 2x squared. So the answer is going to be what? X squared. Then negative 4x minus 3x is going to be what? Negative x. So now and 4 comes down. Now x squared divided x squared is going to be what? It will be plus 1. So 1 times x squared, it's x squared minus 2x minus 3. So let's subtract this. X squared minus x squared. So negative x minus 2. So the answer is going to be x. And 4 minus 3 is going to be 7. So the answer here is going to be x plus 1. Okay, plus x plus 7 over x squared minus 2x minus 3. We're searching about our end behavior. So our end behavior here is what? Is a linear function, which is x plus 1. So our end behavior for the graph, for the rational function, is going parallel with the end behavior of what? Of the linear function. So what we can say now for the end behavior? What are we going to say? That lamb, it's f of x as x go to the negative infinity, and lamb f of x as x go to the positive infinity is going parallel with the end behavior for x plus 1. It's a linear function here, x plus 1. So as x increase, y increase. As x decrease, y decrease. So as going to the negative infinity, always the function is going parallel with that. So it's going to the negative infinity. And as x going to the infinity, also the function going to the negative infinity side. So this is the end behavior when we have a slant asymptote going parallel with what? Going parallel with the function. Now let's do this example. X squared minus x plus 2 over x minus 3, since the degree of the numerator is more than the degree of the denominator by 1. So of course it's going to be slant asymptote, linear one. So let's find that. So x squared minus x plus 2 over x minus 3. So you can pause the video and try to solve this, then check it with our solution. So x squared divided by x is equal x. X times x is equal x squared. Then x times negative 3 is going to be negative 3x. What we're going to do here, we're going to subtract. So negative x minus 3, so it's going to be what? it will be 2x plus 2. Then 2x divided by x, it will be plus 2. So 2x minus 6. So we're going to subtract. So 2 minus 6, it will be 8. So the remainder 8. So the answer here is going to be x plus 2, okay, plus 8 over x minus 3. So what is the end behavior here? The end behavior is x plus 2, which is what? It's a linear one. It's a linear function. So the end behavior is going parallel with the end behavior for x plus 2, which is like this, 2x plus 2. So we can say that lim f of x as x go to the negative infinity and lim f of x as x goes to the positive infinity here is approaching what is going to the infinity. For the negative infinity is going also for the negative infinity, and for the positive infinity also is going where? Is going to the positive infinity. Okay. Now let's find the end behavior for this one. Also here we have the degree of the numerator is greater than the degree of the denominator by 1. So also it's what is a slant asymptote. So let's do this one. So let's divide 6x cubic plus 13x squared minus 5 over 2x squared plus 3x plus 0. Okay, so 6x cubic divided by 2x squared is going to be what? It will be 3x. So 6x cubic here, then plus 9x squared. Actually, we have to add the 0 up here, plus 0x minus 5. Plus 0x minus 5. Okay, 3x times negative 10. So it's negative 30x. Now let's subtract. So 13x squared minus 4x squared. Sorry, minus 9. 3 times 3 is 9. This is 9. So 13x squared minus 9x squared is going to be 4x squared. Then 0x minus 30. It will be plus 30x. Now the 5 get down. So 4x squared divided by 2x squared, the answer is going to be here what? It's plus 2, only plus 2. Okay, so now 2 times 2x squared, it will be 4x squared plus 6x minus 20. So what we're going to do? We're going to subtract. Now 30x minus 6x is going to be 24x. And here negative 5 plus 20, it's going to be what? 15. So here, this is the remainder, and this is what? It's the quotient. So it's a linear function increasing since the slope is positive. So the end behavior for this rational function is going parallel with the end behavior for our quotient. Also, we can say that lim f of x as x go to the negative and lim f of x as x go to the positive. When it's going to the negative, going to the negative. When it's going to the positive, also going to the positive. Okay. So it is possible for the graph for the rational function to intersect a horizontal asymptote actually, of course, at the middle of the graph. So is it possible in some cases to cross the horizontal asymptote not at the end behavior, actually at the middle of the graph? Of the rational function intersect the horizontal asymptote and the slant asymptote. And the graph of the rational function will never intersect the vertical asymptote. Even we can sometimes in the middle intersect the horizontal asymptote, but the vertical asymptote will never intersect with that. Okay. When the graph of the rational function f of x has a horizontal asymptote, y is equal b, where b is a constant. The output values of the rational function get here close to the b, stay close to the b as input values increase or decrease without bounds. So if we have a horizontal asymptote, so actually our end behavior is going to that horizontal asymptote. But if we don't have a horizontal asymptote, we will get a slant asymptote, or according to the end behavior, quadratic or whatever, we're going with this, the end behavior we will get. Okay. So let's see this one. Now evaluate each of the limit. Since now 10 x to the power 4 and 5x to the power 4. So actually here we have what? We have an equal degree for the numerator and the denominator. So in this case, we have a horizontal asymptote, of course. We have the horizontal asymptote and it will be y is equal coefficient over coefficient. This is equal. So it will be at y is equal what? At y is equal to the horizontal line. So our end behavior is going for where? For y is equal to. So as the f of x going or x going to the negative infinity, our function approach to touch it too and is going to the negative infinity. So also approach to touch what? Approach to touch it too. So since we have a horizontal asymptote, so our end behavior of this function going where? Going for this end behavior. Okay, or for going for this actually horizontal asymptote. So limits approach infinity are really asking about the end behavior of the function. Since this is a rational function, the end behavior is found by examining the degree. So the degree of the numerator is 4 and the degree of the numerator is 4. Also denominator and the numerator. So we have here, as we said, the horizontal asymptote at y is equal to. So when lim f of x as x go to the negative infinity equal to 2, and here also is what? When going to the infinity also is going where? Is going to 2. Okay, let's solve this question. From the graph, actually we need to find the whole. We need to find the zeros. We need to find the vertical asymptote, the horizontal asymptote, y-intercept, here estimating, and the domain. So let's find all of these. Okay, so what is the domain? As we can realize here, we have a gap or discontinuity. We can say the discontinuity here is happening exactly here. At where? At x is equal -4. It's the vertical asymptote. And here, at 7, what do we have? We have a hole. So to find the domain, actually, we're coming from the negative infinity. We stopped at -4 because it's the vertical asymptote. Then we continued from -4. Then we stopped when we approach 7 because we have a hole. Then we continue from 7 to where? From 7 to infinity. So this is the domain of this function. Now we need to find the hole. Here we have a hole at x is equal to what? As x is equal to 7, and we can say y approaching also is equal to 2. Zeros, yes, we have 2 zeros at x is equal -2 and x is equal what? X is equal 2. We have a vertical asymptote? Yes, we have vertical asymptote at x is equal -4. Now we need to find if we have a horizontal asymptote. So actually, if we have a horizontal asymptote, so the end behavior from right and left or left and right going to the same end behavior or going to the same line. But actually what we can see here, that the end behavior going in a different direction. So we can say here that we don't have any horizontal asymptote. So no horizontal asymptote. Actually, is more here we have what? A slant asymptote more than a horizontal asymptote. Do we have any y-intercept? Yes, we can like approximate it as y is equal -12. So we can say at 0 and y is equal approximation is -12. Okay. Here, we need to find the end behavior as we're getting the limit. So, direct, we said when the degree of the denominator is more than the degree of the numerator, we will get a horizontal asymptote where at y equals 0 because the power down, take the horizontal, take it down where? To y equals 0. So what is it here? We have end behavior at y is equal 0. So what is our limit now at the end behavior? So our limit from left side and right side going where? Is going to 0. Why here? Because we have a horizontal asymptote at y is equal to what? Y is equal to 0. Okay, let's do this one. So what we can see here? We need to find the limits. Here the numerator, the end behavior, and the limit.
the end behavior, the numerator is more than the denominator by 1. So direct here, what we will get? We will get a slant asymptote because the numerator is greater than the denominator by 1. So to find the end behavior as the limit now, so we can do our what? We can do our long division or what we can do? I can take now the bigger term with the maximum coefficient to the term with the maximum coefficient together. So I need to find now lem x cubic over 5x squared as x going to the negative or positive infinity. So when we simplify this, so it's going to be lem x over 5. So now when x is going to the negative infinity, so negative a huge number divided by 5, of course the number is going to stay what? Stay negative. So here is going where? To the negative infinity. And lem x over 5 when x going to the positive infinity. Like if I replace instead of x by 1,000, 5,000, million, 10 millions, whatever, over 5. So here also we're going to positive infinity, positive direction. Okay, now this one, we said since the degree is equal to the degree. So actually here we have an end behavior where at y is equal 1. We have a horizontal asymptote. So the equal to actually 2 over 1. So it's equal to 2. So what is the limit here in the both side as the function goes to the negative direction or a positive direction? It will approach to touch y equal 2 in both cases. Okay. Let's see. Now, we need to find the domain, whole, zeros, vertical asymptote, limits. Here we already have the graph to find the limit as asymptote, horizontal asymptote, and end behavior. So let's start do this. First of all, to find the domain, whole, zeros, asymptote, we need to what? We need to factor. So let's factor this. So it's going to be here, x plus 4 times x minus 3 over x minus 2 times x minus 2. So let me make sure we factor correct. Actually not. I need to get two numbers. When I multiply, give me 12, negative 12, and we add, give me 4. So actually it's 6 and negative 2. So this one is going to be x plus 6, and this one is going to be x minus 2. So let's start with the domain. The only number that makes the denominator 0 is x is equal to. So x is equal to is not allowed in our domain. So it's from negative infinity to 2, then stop, from 2 to where? To the infinity. Now, okay, I'm going to simplify this. So when I simplify x minus 2 from the numerator and denominator, I have multiplicity, or I have one extra down in the denominator. So in this case, we're going to say it's a vertical asymptote. It's not whole. So actually, we don't have any holes. Why? Because what? Because here, when I replace it, we have more in the denominator, not in the numerator. Now we need to find what? We need to find the zeros. After we simplified, what is the value that make the numerator equal to 0? Actually, here we have at x plus 6 is equal to 0. So we have it at x is equal what? X is equal to negative 6. Okay, vertical asymptote. Now we need to find the limit notation. Of course, here limit notation, we need to graph it to get the limit. So as x coming approach from 2, from the left side, we're going where? To the negative infinity. So lem h of x, as we're coming to 2 from the negative side, we're going to the negative infinity. And lem h of x, as we go for x from the 2 for 2 from the right side, we're coming for the 2 from the right side, we're going where? We're going to the positive infinity. We're going up. Okay, horizontal asymptote now. Do we have any horizontal asymptote? Actually, yes. Since this is x squared and here also this is x squared. So it's equal degree. So it's going to be coefficient over coefficient. So this is this one x minus 2, x minus 2. So when I multiply this, it's going to be what? X squared. So here, what is the coefficient? 1 over 1. So we have horizontal asymptote where at y is equal 1. So since we have horizontal asymptote, what is the end behavior? The end behavior is going to be the same like the horizontal asymptote. So lem h of x as x goes to the negative infinity, it's approach what? Approach to 1. And lem h of x as x approach the infinity, also its approach to what? Is approach to 1. Okay. Let's do, this is here the last example. We need to find the end behavior, we need to find the horizontal asymptote, and we need to evaluate the limit. So here, the degree of the numerator is more than the degree of the denominator by 1. So we will get actually a slant asymptote. So they ask me not to find the slant, they ask me to find the end behavior. So direct here, we can take t squared over 4t. So this is, we simplify, it's going to be t over 4. So we need to find lem d of t as t is going to the negative infinity, and lem d of t as t going to the positive infinity. So negative infinity over 4, of course, is going to give me what? Will give me a negative number. And this one, it will give me what? It will give me a positive number or a positive infinity. Okay, now we need to find the horizontal asymptote. Since the degree for the denominator more is pull it down, take it down. Take the horizontal asymptote down for where? For y is equal 0. So the horizontal asymptote is going to be y equals 0, which is the same as end behavior for this function. Now here, we need to evaluate the limit. The degree of the numerator is more. So let's do this. It's going to be 3 and 5 over n cubic. So actually, it's 3n squared. So now we need to replace this when n going to the negative infinity. So lem x is going to the negative infinity. What we can realize here, the end behavior is what? Is a quadratic and it's positive. So from the both sides, we're going where? We're going to the infinity. Let's try this. So lem here equal 3n squared. So if I replace here instead of n by any negative number, the answer is going to be what? Of course, it will be positive. So even when we're going to the negative infinity, also the function here, it goes where? It goes to the positive infinity. So here, actually, it's equal to what? It's going to be equal to what? To the positive infinity. Why? Because 3 negative infinity squared. So no more negative. So we're going from both sides to where? To the infinity. So actually, this lesson is very important. We discussed how to find the horizontal asymptote. We discussed how to find the end behavior of the rational function. And again, what is the asymptote, vertical asymptote, holes, all these stuff. So please study them well. Try to solve the questions by yourself and check your answers. Good luck.